For the longest time, the story in AI has been pretty simple. Bigger is better. Just build bigger models, throw more data at them, use more raw power. But that race is starting to hit a wall. It's getting way too expensive and the returns are shrinking. So what if the next great leap forward isn't about getting bigger at all, but about getting smarter? What if the future of AI is all about being adaptive? All right, let's get into it. So here's how we're going to break this all down. First, we'll talk about the big scaling problem everyone in AI is facing. Then we'll look at a really clever first attempt to solve it called the team of experts model. After that, we'll introduce the star of today's show, DynaMoE. We're going to dive into some frankly surprising test results, uncover the key idea that explains why it all works, and then we'll wrap up by talking about what this means for how we design AI from now on. Okay, so let's really frame the problem here. At its heart, it's a pretty brutal truth. As we make our AI models way more powerful, the amount of computer power it takes to run them is just exploding. We're at a point now where just adding more servers, more hardware. It's not just inefficient anymore, it's becoming totally unsustainable. We need a new game plan. And the new game plan really comes down to this one crucial shift, moving from what we call dense models to sparse models. The old way, the dense model, is just brute force. I want you to imagine an entire company where every single employee has to show up to every single meeting for every single project. It's a colossal waste of time and energy, right? The smart way, the sparse model, is more like a modern company. You only bring in the specific experts you need for the job at hand. It's focused, it's efficient, and it's really the only way we can build AI sustainably going forward. So this idea of using targeted specialists led to this really brilliant new way of building AIs. The best way to think about it is you're firing that one overworked employee who's trying to do everything, and you're replacing them with a whole team of specialized consultants. And this concept has a name. It's called mixture of experts, or just MoE for short. Instead of one giant AI brain, an MoE model has tons of smaller, specialized expert networks. And here's the magic trick. It has a router that's basically a dispatcher. It looks at a problem coming in and says, okay, for this task, I need to talk to the grammar expert and the creative writing expert. It's an amazing way to have a model with a massive number of parameters, but only activate a tiny piece of it for any given task. Fantastic idea. But the first version came with some really rigid, hidden rules. Yeah, these standard MoE models basically had two huge handcuffs on. First was this thing called fixed routing. The router always had to pick a set number of experts, let's say 2, for every single piece of information it looked at. A simple word like and, 2 experts. A deeply complex philosophical idea, also 2 experts. You can see the inefficiency. Second was uniform allocation. This meant that every single layer, every department in the network, had to have the exact same number of experts on staff. These rules made them easier to build, but man, were they wasteful. And this is exactly where our breakthrough, DynaMoE, comes into the picture. It's all about getting rid of those handcuffs and building a much smarter, more dynamic team. DynaMoE just shatters those 2 old rules. First, it introduces dynamic routing. The router is finally unleashed. It can now look at how hard a task is and decide to send it to just 1 expert, or maybe 3 or 5, whatever's actually needed. And second, it brings in this idea of layer-wise schedules. Now, that's a bit of a fancy term, but all it really means is we can be strategic about where we put our experts. We can load up some layers with a ton of specialists while keeping other layers lean and mean. And this chart right here makes that whole schedules idea super clear. Just look at the red line. That's a descending schedule. It puts a ton of experts, like 16 of them, right at the beginning of the network, and then it tapers off. The green ascending line does the total opposite. This flexibility, the ability to actually design the shape of the expertise inside the model, is the absolute core of what makes DynaMoE a game changer. Okay, so the theory sounds really elegant, right? But the million-dollar question is, does arranging the AI's internal team like this actually make a difference? Well, the researchers put these different schedules to the test, and the results, well, they weren't just good. They were really revealing. For image recognition, the result was an absolute knockout. Using that front-loaded descending schedule gave the model a massive 5.47% accuracy boost over a normal model. And it makes perfect sense when you think about it. For an image, the hardest part is at the very beginning. It's just a chaotic mess of pixels. You need your best and brightest on the job right away to start finding the patterns. So, for anything with images, the playbook seems clear. Stack your experts right at the front. Easy enough. And this is where things get super interesting. What about language? Does the same rule apply? You might think so. but the data told a completely different story. Take a look at this heat map with me. It's pretty simple. Green is good, it means the AI is making fewer mistakes. So for the tiny model up in the top left, that descending schedule we just talked about is still a strong choice. But now, watch this. When you move to the small model, bam, the ascending schedule, the total opposite, is suddenly the winner. And for the medium model, it's different again. This is the plot twist. For language, there is no single best design. The optimal way to build the AI actually changes as it gets bigger. So, why? Why is language so different from images, and why does the best strategy keep shifting around? This brings us to the core scientific principle that makes everything just click. This is the real aha moment of this whole thing. It's called the representational diversity convergence principle. Now, I know that is a mouthful, but forget the jargon. The idea is actually beautiful and simple. You should put the most experts at whatever point the problem is most complex or diverse. That's it. You just match your firepower to the difficulty of the task at each stage. And this one simple principle perfectly explains everything we just saw. With an image, the diversity, the chaos, is highest at the very beginning, in that sea of raw pixels. The AI needs a huge team up front, and then the task gets simpler. But with language, it can be the total opposite. A model might start with a single word, which is pretty simple, but as it reads a whole sentence, it has to build a way more complex understanding of grammar, context, and meaning. The diversity, the complexity, can actually increase the deeper it goes. All right, so let's zoom out. What does this all mean for the people who are actually building the AI systems of tomorrow? Well, it suggests we need a fundamental shift in our entire design philosophy. The bottom line is we now have a new, smarter playbook. If you're working on image tasks, a descending schedule is your best bet. For language, you're probably better off with an ascending or maybe a pyramid-shaped schedule. But the bigger lesson, the real headline here, is that the era of one-size-fits-all AI is over. The best design is adaptive. It depends on the task you're trying to solve and the scale you're solving it at. It's not about being bigger anymore, it's about being better designed. When you boil it all down, DynaMoE succeeded because it challenged two basic assumptions that everyone in the field just took for granted. And that really makes you wonder, doesn't it? What other unwritten rules of AI design are we all following without even thinking about it? What other big ideas are just waiting for someone to come along and break the rules to unlock the next generation of smarter, more efficient intelligence?